All right, we have our last example here. You might notice right away that there is a number that you can factor out of every term in this equation here. I can see that a -2 can be taken out of every equation or every term in this equation. So what I'm going to do first is I'm going to write -2, and then I'm going to divide -2 out of each term, which leaves me with an x squared plus 4x plus 3. And I'm really excited because now that leaves me with an a term that's just 1. So I can do my shortcut here with factoring. My two numbers that multiply to a +3 and add to a +4, I'm thinking that's going to be a 1 and a 3. So that's my factored form. As for my x-intercepts, that's where those factors are set equal to 0. So for the first one, for the x plus 1, if I set that equal to 0, that's going to get me x equals -1. For the other x-intercept, I'm going to get x equals a -3. My y-intercept is always found from that c term. It's that last term up in the standard form. This one. And my c term for this guy is -6. So that's why that y-intercept is going to be a -6. Remember, the a is the one that's in front of the x squared, and the b is the one that's in front of the regular x term. I guess if I want to write my x-intercepts as points, I could write those as -1, 0 and as -3, 0. For my vertex, I'm going to use the same equation that we learned on example 2. That's the x equals -b over 2a. Now my b term, remember, is my -8. My a term is -2. So my x is going to equal -8 over 2 times -2. And a -8 is a +8, and 2 times -2 is -4. And simplify that, and your x value of your vertex is -2. And now if I plug that into the original equation, I plug -2 in, y equals -2 times -2 squared. In my head, what's -2 times -8? That's 16, and then -6, and if I add those terms up, -2 times 2 squared is 8, -8, and then plus 16 minus 6, and when I put those all together, I get a 2. So when I write my vertex, it's -2 for my x value and a +2 for my y value. When I go to fill in my xy table, I want to include my vertex and my x-intercepts and hopefully my y-intercept as well. So the nice thing is they're kind of all close together on this problem because the x values of my x-intercepts are -1 and -3. My vertex is -2, and of course the x value on my y-intercept is 0. I'm going to plug in what we already found. Now, it asks for the line of symmetry. And I want you to know that parabolas are symmetrical. So whatever happens on one side happens on the other. You know, the y values are going to stay symmetrical going up the side. So when I look at that on this problem, I should see right now that I am starting to have symmetry on my x and y table. And when I graph these points, okay, it's starting to form a parabola that is upside down. And so that x value of -4 should have a y value of -6 as well if it's going to be symmetrical. Now, this line cutting down the middle of my parabola that makes it cuts it exactly in half, that's the line of symmetry. And it's just a vertical line, so we know that vertical lines are always x equals lines. And the x value that's true along that entire dotted line there, those are all going to be negative 2's. So my line of symmetry is x equals negative 2. Also, it would be the formula for the line of symmetry happens to be the same as the x value of my vertex. So you can plug that, make sure that you get that formula on your notes somewhere, because that is really important. So if you just see that dotted line down the middle, that's your line of symmetry. And I think that you guys have, spent a lot of time working on those throughout your schooling. So that is how you do this entire section. Obviously, this one was very rapid, so you might want to watch this video a couple times. And in general, make sure that you're not doing too much math every day. Keep in contact with me, email me. I'm going to be sending home some more communication. I think that you guys are awesome. You're getting through this stuff. Make sure that you're on the Zoom meetings to ask questions. And best of luck. Love you guys. I miss you guys. I'll talk to you soon.